Hello, hi, welcome. I'm Suresh from IARE College, Dundigal, Hyderabad. In today's class, we discuss about principle of photogrammetry survey. So far, we are aware of what is photogrammetry survey. Now we discuss the principle behind photogrammetry survey. Now, the principle of photogrammetry survey in its simplest form is very similar to that of plane table surveying. So photogrammetry survey is very similar to that of your plane table surveying. So what is plane table surveying? Is a method of survey where a graphical representation of a map or a plan is plotted simultaneously on paper as well as on ground. So if you take a plane table, on plane table you have a tripod stand, and if I give a centering mark using the plumbing fork like this, we have plumb bob somewhere pointing here on the ground. So the point on the paper and the point on the ground are drawn simultaneously. So if I bisect, if I draw a line of AB of 10 meter, 10 centimeter on paper, it indicates that A to B is about 10 meter on ground. So plane table survey is a method of survey where a graphical representation is done of a map or a plan is done simultaneously on paper as well as on ground. So here in photogrammetry is also the principle of your plane table surveying. It is very similar to the plane table survey. Why? Because in photogrammetry we capture the images directly as how we measure in plane table surveying. We capture them directly and we obtain the physical quantities of an object in photogrammetry. Okay. So whereas in plane table also we obtain the area of particular object by radiation method or inaction distance by intersection method. Similarly, in photogrammetry also we can obtain the physical quantities of an object. Like suppose if you take a height of a building, this is a building in your photograph, we can find the length of the building, depth, height of the building, width of the building, and length of the building also. We can find the 3D view of an object in photogrammetry. So only difference is that the most of the work with in plane table survey is executed in the field is done in office. So we have one difference here. I have make a difference here. In photogrammetry, we are done in the field, whereas in the plane table survey is executed in the field, and the photogrammetry survey is done in the office. One difference is that the most of the work which in plane table survey is executed in the field is done in office. So whereas in photogrammetry we work in office, we record the data using airborne vehicles, and we sit in the office and we work on the data to extract the physical quantities of any object which we have captured. Whereas in plane table, we go to the field, we work physically, we have physical contact with the instrument and ground, we measure with the measuring tape and we record on the drawing sheet. Whereas in photogrammetry, only by capturing the images in office work, we go for the analysis method by visual image interpretation technique or digital image processing techniques, and we extract the information of whatever data we have captured. The principal point of each photograph is used as a fixed station, and the rays are drawn to get the point of intersection very similar to those used in plane table surveying. So if you imagine in plane table survey, we know very well we have a tripod stand, we have centering here. So using the plumbing fork, we have a plumber focusing the centering point and a point on the paper. So with this center, we draw radial lines or we do any work. If you join this A, B, B, C, C, D, D, A, E, F and F, A, we get a radial figure here. So with this, we can find the area of each triangle using a formula, and we can extract the total area of this field is suppose 203 square meters. Like this, we do in your plane table surveying. Whereas, in plane table surveying, the center point is a centering point on paper and on ground are similar. In that manner, in that way, we call principal point. Principal point of each photograph is used as a fixed station to draw the rays and to get points of intersection very similar to those used in plane table surveying. Suppose in your plane table surveying, this is an aircraft. Sorry. have captured a photograph from exposed station, and one ray is falling on the center of the photograph, and this is the area which is measured on the ground. Okay, so the rays are falling like this. This is the principal point, this is ground nadir point, this is the photo principal point, PP. Okay, or principal point or photo principal point is a PP. So the point on the photograph and the point on the ground. So this point on the photograph is used as a fixed station, and rays are drawn to get the point of intersection, very similar in the plane table surveying. So in plane table surveying, this point in plane table surveying, we take a centering point using plumbing fork, whereas in this we take as a principal point in photogrammetry survey. Okay, so in this photograph survey also we can get the physical quantities. Here also we get the physical quantities. Both are similar, and here we call a centering point. Here we call as principal point or photo principal point. That's the difference. So this is why we are calling quite similar. And this is done in office work. After extracting everything, we do in office work. This is done in field work. Okay, this is done in field work. This is done in your office work. It is suitable for topography or engineering surveys, and also for those projects demanding higher accuracy. So this photogrammetry survey is very suitable for topographic surveys, topographic or engineering surveys, and also for those projects demanding high accuracy. So if you want to capture a photo of a dam or reservoir or very big structure, okay, or watering door, we want to capture any photo or topographic features like mountain, hills, slopes, lakes, plain, plateaus, whatever it is. So for those survey, this photogrammetry is very preferable. Okay, photogrammetry is very preferable for topographical or engineer survey. Okay, used also for those projects demanding higher accuracy. So if you want to measure the length of a dam, okay, we have a dam here, spillways are there, this is a reservoir. You want to measure the length of the dam or width of the dam, something, okay, some quantities. So L or B or D or something you want to measure. So this can be done like engineering surveys requirement. In engineering survey I want to measure some physical quantities of a dam. On a topographic survey I want to measure the height of the hills presenting on either side of the dam. I want to find the height of the hills or slope of the hill, whatever it is. Okay, so this can't be done using your plane table or chain or compass or theodolite surveys. So photogrammetry surveys can only do these physical quantities whichever you want to require, which are having higher demand or high accuracy. It is unsuitable for dense forest and flat sand due to the difficulty of identifying points upon the pair of photographs. So this is one of the disadvantages, you can say, not a principle. So it is unsuitable for dense forests and flat sands due to the difficulty of identifying points upon the pair of photographs. I'll say what are the points in the next slide. Yeah. Okay. Suppose you take a photograph like this. This center point I'm calling as PP, principal point on photograph. So this principal point is a line passing from camera axis and falling on the photograph. So if you have a camera axis like this, from the line passing from center of the camera axis and to center of the photograph is called principal point. And this camera will focus in all the four directions like this. Okay, and from here it passes to the ground. Like this. So on ground you can see some different type of images. So this is a photo in the film, and this is the portion which you're capturing on the ground. So if there is dense forest or flat sands are there, due to difficulty in identifying the points upon the pair of photograph. So there may be some difficulty in identifying pair of the photographs. Why? Because at exposition 1 O1 I have captured a photograph here. At next exposition O2 I captured one more photograph, and the points which are lying on the edges. So there are some points which are lying on the edges of the photograph. These points are called peripheral. The points which are lying on the edges of the photograph are called peripheral marks or points. The points which are lying on the edges of the photograph are called fiducial marks or fiducial points. The point which lies in the center of the photograph is called principal point. And these fiducial marks are taken as, fiducial mark and principal point are taken as spatial reference point. So in photogrammetry, I will overlap the 60 to 70% of previous image. Yes, I will overlap 60 to 70% of previous image. So when I am overlapping the previous image, I will overlap this 3 fiducial point and 1 principal point and this 4 too. 1, 2, 3, 4, 4 fiducial marks and 1 principal point. So these all are overlapped. So in taking new photograph here, I should overlap the previous image by 60 to 70%. Again here I'll overlap this image by 60 to 70%. Again here I'll overlap the previous image with 60 to 70%. Like that I will overlap a series of images with the help of these points. Okay. So if there is a dense forest or flat sand is there, so identifying of the points upon the pair is difficult. Which points? Fiducial marks or fiducial points and photo principal point. So this is unsuitable for dense forests and flat sands due to the difficulty of identifying the points upon the pair of photograph. If these points are visible only, we can take the next image by overlapping the 60% of these points. Right? That is how the principle of photogrammetric survey works. So the next principles are there. The photographs used in photogrammetry may be broadly classified into two types depending upon camera position at the time of photogrammetry. So one is vertical photograph, one is aerial photograph. So based upon the camera, so in photogrammetry, photo means light, gra means to draw and metry means to measure. So in presence of photo, we'll draw and measure. So in photogrammetry of two types, one is aerial photogrammetry, one is terrestrial photogrammetry. Now what is terrestrial photogrammetry? Suppose I want to capture area of this particular region. There are some 20 tall buildings are there. There are 20 tall buildings in a particular city or region. So what I'll do, there are 2 towers are there on the other side of the town. It's a town here. There are big towers are there, or hill stations are there, or any high altitude objects are there. So for these towers, what I'll do, I'll fix a camera of equal altitude from ground. What is the height I'm keeping here? H1. The same height I will keep for the next tower also H1. So at the same interval of same altitudes, I fix 2 cameras. One camera will focusing on the town, which is on left hand side. The camera on right hand side will also focus the same town. Okay. When I go for stereoscopy, I can get the 3D view of this particular buildings, and I can also get the parallax error. Okay. So this is called terrestrial photogrammetry. So the photograph which are captured from terrestrial heights by having equal altitude is called, with 2 different cameras, it's called terrestrial photogrammetry. So the photograph is captured, the same photograph is captured by 2 cameras from terrestrial heights is called terrestrial photogrammetry. So here the photographs are placed on above or beneath the ground surface. So here the photographs are placed on above or beneath the ground surface of equal altitudes or heights. Next one is aerial photogrammetry. Suppose there is a town here, the same town with some 20 tall buildings. I want to find the height of this town. So what I'll do, I'll take an airborne vehicle. I'll take an aircraft. And this aircraft will capture the entire town in 2 or 3 exposed station points. Okay. Initially, the aircraft is first aircraft was here. Okay. Here it captured the 60% overlap. It will capture one image, and again it is capturing the image like this. So here first picture, second image, and third image. So we're having 3 images are there. In aerial photogrammetry, we capture the photograph by using airborne vehicles. Okay. In earlier days, we use aircraft or parachutes or balloon or some pigeons, different types of instruments were used to capture the aerial photograph. Or satellite images also we can take to capture the aerial photographs. Now we discuss about this aerial photogrammetry and terrestrial photogrammetry in detail. Photographs are taken from camera stations at a fixed position or near the earth or ground is known as terrestrial photogrammetry. So photographs are taken from camera station at fixed positions or above or near beneath the ground surface is known as terrestrial photogrammetry. The photographs are taken by means of phototheodolite, which is combination of a camera and a theodolite. I will show you the image of phototheodolite how it is. Okay, so this theodolite is placed at top of hill stations or towers wherever it is. So from there you can capture the entire area of the particular region. Here also we have one phototheodolite. It will capture the previous point like this. Okay, when you overlap these two using stereoscopy, you get the physical qualities of the object present in this particular location, right? The photographs are taken by means of phototheodolite, which is the combination of camera and a theodolite. So based upon the principle, that is, its directions of the same objects. I read here. If the direction of the similar object photographed from two extremities of measured base are known, their position can be located by the intersection of the two rays to the same object. So that was a drawing here. So there is 20 towns in a building. I know the height of the position of the cameras. I have captured the left side view and here I'll capture the right side view like this. So if I overlap these two images, the left side and right side view, if the direction of the same object photographed from two extremities of measured base are known, their position can be located by intersection of the two rays to the same object. So I'm intersecting the positions 1, 2, 3, 4, 5, 6, 7, 8. From this side I have 4 rays. Here I have again 4 rays. So if the intersection of all the objects rays, I using stereoscopy, I can extract the physical quantities of an object using your terrestrial photogrammetry. See here. As I said now, in terrestrial photogrammetry is a combination of theodolite and camera. You can see here telescope is there. It have a camera and theodolite. Okay. Here also. These all are the images of your terrestrial photogrammetry. So photographs are taken from elevated ground stations. Why? Because we can't take from the on the ground because elevated ground station. It should be some feet height above the ground. It may be a hilly area or hillock, or it may be a tower, or it may be trees, or it may be anything. Wherever you want to take the photographs, you see here, it should be suitable for us. So if there is depression here, I can go for a hill station and capture the image. Okay, using stereoscopy or stereo pairing, I'll extract the information like this. So it should be an hill station or a depression. So photographs are taken from elevated ground stations only. This method is very similar that the camera is in stationary position. So there is no more errors when compared to aerial photogrammetry. Okay, because camera is in stationary position, so camera is not moving, so there is no error of relief displacement or tilting error. Okay, whereas in photogrammetry the aircraft is moving, there are vertical error is there, it may be vertical photograph or oblique photograph, many type of photographs are there, many errors are there in aerial photogrammetry. Whereas in this case the camera station is fixed, is stationary, so it's very similar that the camera is in fixed position. Camera used in this method is called phototheodolite. It's a combination of camera and theodolite, as it is well required the same features of a theodolite. It is much cheaper and can be carried out by individual surveyor firm also. So it is very compared to aerial photogrammetry, it is very cheaper and it can be carried by individual surveyor firms also. So it is not suitable. I mean, if you want to speak of limitations, this what is this for terrestrial photogrammetry? Okay, this terrestrial photogrammetry is not suitable for very vast region. It is only for, it is fixed. It should have some fixed boundaries so that this method can be suitable. If you want to survey a complete area of Hyderabad or Telangana or some like stations, okay, entire GHMC Greater Hyderabad or Outer Ring Road area, okay, then this photogrammetry method is not suitable, right? If you want to survey a campus, Usman University or JNTU, okay, small region, so it can be done only for small region like some buildings, small towns where we don't have many obstructions, okay, in such area only, in such region or field, this method is suitable, right? Now we go for aerial mounted camera or aerial photogrammetry. So second type is photographs taken from aerial mounted camera on an aerial vehicle. So photograph used for various purposes, mainly extraction of information on the ground surface. Okay, so these two photogrammetry, aerial photogrammetry as well as terrestrial photogrammetry, both are used to extract information on the ground surface. But compared with terrestrial photogrammetry, aerial photogrammetry gives you more information on the ground surface. Okay, so aerial camera mounted aircraft are used in aerial photogrammetry. So this is used to extract information on the ground surface. Okay, which information? Height of the building, length of the width of the road, or length of the building, depth of the pond, anything you can extract. Okay, aerial photographs are obtained from aerial cameras mounted on airborne vehicles like aeroplanes for the purpose of photogrammetry. Or we can use aeroplanes, we can use parachute, we can use some balloons. Okay, we can use helicopter. Various airborne vehicles are there, not only aeroplanes. Used for various purposes, mainly information extraction on the ground surface. These both are same point. Photographs are taken from camera stations in air with the axis of camera held vertically or nearly vertical. Whereas if you take terrestrial photogrammetry, we have a tripod stand, we have a photo telescope, and the telescope have a camera and a theodolite. Okay, we have a camera and theodolite like this. So this can capture some data like this. Okay, here also we have telescope and eyepiece. It can capture some information like this. This is happening only in terrestrial photogrammetry. Whereas in case of aerial photogrammetry, we can capture image. I mean, in terrestrial photogrammetry, the image is always oblique. Why? Because in terrestrial photogrammetry, you capture the image in some incline, with some inclination, you're capturing the image like this, right? This is a tripod stand. This is the ground where you're capturing the image. Here also we do the same thing from left side, right? This always the images are oblique or inclined. Whereas in terrestrial photogrammetry, your image is not oblique. Your image may be oblique, high oblique, or low oblique, or vertical. That is the difference between terrestrial and aerial photogrammetry. In aerial photogrammetry, where is that? So here in terrestrial photogrammetry, we get only oblique photograph. Why? Because the camera is on the ground, it can't take a vertical photograph. We can capture only then oblique photograph, left side view and right side view. Whereas in aerial photograph, we can take a vertical photograph, or we can take an oblique photograph, low oblique photograph, or an high oblique photograph. Okay, we can take a low oblique, high oblique, and vertical photograph. So we have these type of photograph in your aerial photography. Okay, I'll show you the images example for these photograph in next slides. It's a branch of photogrammetry where the photographs are taken from air stations or exposure station. Okay, so the point in atmosphere where a photograph is captured is called an air station or exposure station. So in aerial photogrammetry, we can find exposure stations or air stations when compared to air terrestrial photogrammetry. Terrestrial photogrammetry, we work for any exposed stations, we can find a centering point, centering point, a principal point on the photograph itself. That's it. It's a best mapping procedure yet developed for large objects and are useful for military intelligence. In the aerial cameras are used with the fixed on flying aircraft. Aerial photogrammetry, aerial cameras is used which are fixed on flying aircraft. So this is the difference between aerial photogrammetry and terrestrial photogrammetry. Very simple. In terrestrial photogrammetry, we use a tripod stand and a camera and a phototheodolite. So we go for an altitude. If you want to capture an image, if you want to take an image of a particular zone or area, we take two altitudes of equal height. We place the camera on left hand and right hand. We take the photograph from left view and right view. Using stereo pairs, we extract the information in terrestrial photogrammetry. Aerial photogrammetry, directly aircraft will capture the image, measure, record, analyze, and interpret the data. We get the application of the particular image. Right? Now you can see the views here. This is a vertical photograph, low oblique photograph, high oblique photograph. So for aircraft, if you take an aircraft like this, so if the camera is placed here, we get a vertical photograph. If you take an aircraft like this, if the camera is placed somewhere here, we get oblique photograph, low oblique and high oblique. Okay, high oblique. This is low oblique photograph. This is a vertical photograph. Okay, this is how aircraft will capture the image. If the camera is on sides, this side view or this side view, low oblique, high oblique is a vertical photograph. So these type of photographs are possible only in aerial photogrammetry. According to the direction of camera axis at the time of the exposure, aerial photograph may be classified into vertical or oblique. In vertical photogrammetry, nearly or vertical or nearly vertical, a truly vertical photograph closely resembles a map. It is utilized for the completion of topographic and engineering surveys on various scales. So here, vertical photographs are taken from the air with the axis of camera vertical or nearly vertical. If you see in this image, okay, see, you take this image, it's an example of your vertical photograph. So this is how this part, if you take this image, this section, this part is in your camera, in your aircraft. Okay, this entire structure, okay, whatever you're seeing here, okay, this is in your aircraft only. So now from here, this is a plumb line, right? This is a plumb line, and the aircraft is capturing a vertical photograph from atmosphere. So where it is taking the first photo is called exposure station 1, right? Photo taken from the air with the axis of the camera vertical or nearly vertical. So we call vertical photo or oblique photo. If the camera axis is if the plumb line, okay, is exactly 90 degrees, it's called vertical photograph. And if the camera axis, so we have plumb line is there, as well as we have a camera axis also there. So the axis passing from center of the eyepiece to object piece, photo principal point and ground principal point. So the line passing from center of the camera lens, object piece, photo principal point and ground principal point. This is called camera axis. So if the camera axis is not inclined more than 3 degrees, is called a vertical photograph. If camera axis is inclined more than 3 degrees, is called an oblique photograph. So we have two types. One is vertical photograph, one is oblique photograph. If the camera axis is not inclined more than 3 degrees, it's called vertical photograph. If axis is inclined more than 3 degrees, it's called oblique photograph. So example for this is this low oblique and high oblique. Okay, and plumb line. If plumb line is not inclined more than 90 degrees. Okay, if plumb line is 90 degrees, it is called vertical photograph. If plumb line is 60 degrees, it's called oblique photograph. Based upon the angle, it is called oblique. and high oblique or low oblique, right? You can see an image here. So this is a vertical photograph. This is an oblique photograph. From here we are capturing the image. It's an oblique photograph. See, this is an oblique photograph. See how the image is capturing. Okay, not if it is like this, it is a vertical photograph, but the camera is not exactly vertical. The aircraft is capturing an oblique photograph. Extents of photo coverage, right? Here also you can see this is oblique photograph. The camera is capturing this portion. The camera is capturing this portion. This is a vertical photograph. This is an oblique photograph. Okay, so based upon the camera axis and plumb line or plumb line, camera axis or plumb line. If camera axis is not inclined more than 3 degree, it's called vertical photograph. If inclined more than 3 degree, it's called oblique photograph. If plumb line is more than 60 degree, it's called oblique photograph. If plumb line is 90 degrees, it's called vertical photograph. Please remember these fundamental values. Yes. Now discuss about oblique photograph. Okay, just now we covered what is vertical photograph in this class. Oblique photograph and low oblique photograph and high oblique photograph. Now what is an oblique photograph? We are saying that the camera axis is not exactly 90 degrees. Okay, the plumb line is not 90 degrees and the camera axis is more than 3 degree. Okay, camera axis more than 3 degree. Then we are calling as an oblique photograph. Again in oblique, we are having low oblique and high oblique photograph. So photographs are taken from air with the axis of camera intentionally tilted from vertical. Okay, why we are taking this intentionally tilted from vertical? Because if you take a vertical photograph, we can see only small image in this photograph. Okay, if you take an oblique photograph, we can cover more area. Okay, oblique photograph can cover more area than a vertical photograph. This is plumb line. It is plumb line here. It angle 30 degrees. It angle is 90 degrees with Earth. Plumb line. In vertical photograph, it covers small area when you compare to an oblique photograph. So that is the main advantage why we take an oblique photograph. And this is a low oblique photograph. We also have high oblique photograph also. Go like this. So in high oblique photograph, we observe sky and earth are together. A photograph in which we can observe sky and earth are touching each other, that is called high oblique photograph. High oblique photograph. And we can see only the objects, that is called low oblique photograph. And we can observe very small region, is called vertical photograph. An oblique photograph covers large area, just now I said this point, covers large area on the ground, but clarity of details diminishes towards the far end of the photograph. There is no clarity. It's a vertical axis and it covers like this. So in oblique photograph, we can see that sky and earth are together. They're touching together each other. Okay. So depending upon the angle of obliquity, oblique photograph may be further divided into two categories: low oblique and high oblique photograph. Now see what is low oblique photograph. An oblique photograph which do not show the horizon is known as low oblique photograph. What is horizon? Suppose exposition, a point here, okay, this point, this point, this point and this point. This point is called horizon, H. So low oblique photograph which does not show the horizon is known as low oblique photograph. So a series of the flying line, this is photo principal point. A line connecting photo principal point and her flying line is called horizon. Okay, so low oblique photograph does not show horizon. An oblique photograph which do not show horizon is called low oblique photograph. Such photographs are generally used to compile recognition map of inaccessible areas. A photograph which is a photograph which is sufficiently tilted to show the horizon, nothing but we can see the sky and earth are touching each other. Then you can see the horizon also. It is known as high oblique photograph. Such photographs where previously used for the extension of planimetric and high control in areas having scanty and ground control. Scanty ground control. I'll show you image for this. Yes. Now you can see the images for high oblique, low oblique and vertical photograph. So it is a vertical photograph where the camera is placed at the bottom of the aircraft. So vertical photograph better for making map and plans. It is a high oblique photograph, high and low. For oblique photograph, the camera placed at the sides of the aircraft, not at the bottom. If you place bottom, it is called vertical photograph. It's called oblique photograph. Now, better for pictorial effects and perspective. This is better for making map and plan. So you can see this is a vertical photograph. It is an oblique photograph. In vertical photograph, you can make a plan or a map. See here, I can make a map of this particular venture or field. So here in this venture, there are some solar panels are there, some buildings are there, some farmers are there. Something I can represent in this. So I can make a plan or map for the in vertical photograph. In oblique photograph, just you can see the construction or the development of society. Okay, we can see some buildings. We can find the height also here, height, length and width of the building also. This is some venture is there. We can find some parameters. So in vertical photograph, we can measure only a map or a plan, whereas in oblique photograph, we can take the pictorial effect of the photograph. So photogrammetry, we can see here. John Way Airport in vertical photograph, in oblique photograph. So in here, the example of a vertical photograph I am representing here. So in this John Way Airport, we can see some runway here. We can see some indication. We can see 40, 73, 55, 405 road numbers. This John Wayne Airport, oblique photograph. So it's saying an airport is here, but it is not showing a plan or a map of the airport. Whereas in this image, it can represent a plan and map of an airport in vertical photogrammetry. In oblique photogrammetry, you can see that the sky and the earth are connected with each other. So this is an high oblique photograph. High oblique photo. A photo where sky and earth touch. A photo which represent the touching of eye and earth together is called an high oblique photograph. And photograph which shows only the structure. This type of structure is called low oblique photography. Example of low oblique photograph. Here the axis is tilted more than 3 degrees and the the camera, yeah. This is low oblique photograph and the plumb line is not inclined more than 60 degrees. Okay. The high oblique photograph, the plumb line is inclined more than 60 degrees. We can see earth and sky are touching together. Example for your vertical and oblique photographs. Now, photo theodolite. As I discussed that there are aerial photograph and terrestrial photographs are there. So we have a photo theodolite also. So this type of theodolite we can see this is similar to your theodolite. So this theodolite can take a photo. So we are calling as a photo theodolite. And this photo theodolite is used in terrestrial photogrammetry. So terrestrial photogrammetry take photograph using theodolite. This theodolite is called photo theodolite. Okay. Construction and use of photo theodolite PU 2006 is the code of the theodolite. It's a combination of camera and theodolite mounted on the same tripod. You can see a camera and a theodolite in this itself. Okay, you can see camera and a theodolite in one setup, mounted a tripod stand like this with 3 foot to method 1, 2, and 3. 3 foot are the lower tripod is the upper tripod. It is similar to your theodolite, but we have a camera and a telescope. That is why we are calling as a photo theodolite. Okay, used in terrestrial photogrammetry for map making and other purpose. Photographs obtained are used for the construction of photographic maps, classification of soil, interpretation of geological features. While making a photograph, the camera axis is kept parallel to each other. It consists of a camera box. You can see a box here with fixed focus type, a hollow rectangular frame placed vertically on the rear side, and the sensified photogrammetric plate. Okay, these are the components of your photo theodolite. Apart from these, you can see tribads are there, foot screws are there, tripod is there, lower plate is there, right? Some other components also you can observe in your photo theodolite. A camera box is supported. This camera box is supported on a tripod and furnished with an inner and outer axis, each of which is fitted with a clamp of fine adjusting screws. So, like we have a clamp screw, upper clamp screw, lower clamp screw, upper tensile screw, lower tensile screw. Similar, the same screws are there in your photo theodolite. So, the graduated horizontal circle carries vernier readings to single minute. There we have 20 seconds least count. Okay, so here the least count is single minute. This is supported on a leveling head carrying 3 foot screws. Just now I explained about 3 foot screws. Okay, on the top of the box, a telescope is fitted. You can see here. The telescope can be rotated in a vertical plane above the orbital axis and is fitted with vertical arc with vernier clamp and slow motion screw. The line of sight of telescope is set in the same vertical plane as the optical axis of camera. So this camera and the vertical axis, camera and telescope are both are parallel to each other, and the telescope line of sight of telescope is set with the same vertical plane as the optical axis of camera. These are similar. Okay, so that's for today's class. So we have seen vertical photograph, oblique photograph, principle of photogrammetry, what is plane table surveying, and what is a photo theodolite. Okay, so we have a photo theodolite also. It is a combination of theodolite and a camera with a wooden box, upper tribads, lower tribads, and 3 foot screws and tripod stand. Right. So this is for today's class. Thank you. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.